All right. Hi, everyone. Happy Election Day. Um, hope everyone's feeling okay. It's an anxious time, but we'll make it through it. Miss Minna is here with me. I'm actually in her apartment. So that's okay. We've been doing PDs all day, and I've just been taking this time to like make material for you guys. Not that I want to put more work on you, but that I want you all to have more resources, right? Okay. So let me share my screen. Let's take a look at the PowerPoint that we are going to have posted. Technically, I guess I'm honestly not sure if today was supposed to be asynchronous or if we were just not having school. So here we are. I'm just gonna post it and it'll be okay. It'll be fine. We're gonna take a look at this PowerPoint because I was gonna have to make a video on it regardless, right? So here we are. We're gonna talk about transformations of tangent and cotangent graphs. All right. So let's just quickly remind ourselves what a regular tangent of x equals y graph and what a regular cotangent of x equals y graph looks like. Notice, right, we have our three invariant points, right? We have the point in the center, and then we have the point that goes up vertically, the point that goes down vertically, right, for both of them. And then we also have our vertical asymptotes. Notice that the periods are pi, right? You can see here from 0 to 3.14 here, and then this way is half pi, and this way is half pi for tangent. All right, and then notice wherever tangent is equal to 0, that now becomes a vertical asymptote for, let me pause the meeting real quick. Hi, I'm gonna use the shoes on. All right, I'm back. Sorry about that. Let me keep sharing my screen. Okay, here we are. Share, present. Okay. So again, just as a reminder, these three variant points, right? We have our vertical asymptotes, and wherever tangent is equal to 0, that now becomes an asymptote. So you can see here at y equals, or not at y, sorry, where x equals 0, that is now a vertical asymptote for cotangent, right? Over here, where tangent of x equals 0, right? That is now a vertical asymptote. And also keep in mind that tangent is a continuously increasing function, right? We know that like the slope right here is increasing at every one of these little intervals. And then for cotangent, if you're looking at positive cotangent of x equals y, that is actually a decreasing function, which should make sense, right? Because we talked about yesterday where the denominator increases, right? The fraction decreases. So where tangent is increasing, cotangent is decreasing. Hopefully that makes a little bit more sense now, okay? So let's just keep this in mind, right? Let's keep these three variant points in mind, and let's keep these vertical asymptotes in mind when we go to graph our transformations of the functions, okay? So again, let's just talk about our general form, right? So we've got y equals a f of bx plus c plus d on the outside, right? So here we're going to be talking about tangent and cotangent, all right? So we're going to plug those in. Now, how does this kind of differ from secant, cosecant, sine, cosine? Well, the amplitude, right, our A, our amplitude, it looks a little bit different. It's no longer the range for the little wavy line. It's actually going to be the positions of those two outer invariant points, right? Here we've got this central variant point, right, on both of these. And then we also have these two outer invariant points, sorry, these two outer invariant points. And the amplitude is going to tell us how high, right, or low these are on the vertical axis, okay? So the amplitude, again, it talks about how high and how low you go, same thing, except here we're changing these invariant points to make them higher or lower. Or here, if we're looking at cotangent, we're changing this one to make it higher or lower, and we're changing this one to make it higher or lower. And that will also help us determine where this very central point of everything is going to be, higher or lower, okay? So for B, right, that is, again, going to help us find our period, but no longer is our formula going to be P equals 2 pi over B, right? That is for sine and for cosine because the period of those is 2 pi long. That's why we use 2 pi in the equation. Now, actually, when we're looking at tangent and cotangent, our period is going to be equal to pi over B because the period for just tangent alone is 1 pi. Let's look at this right here, right? The period for cotangent from 0 right here to 3.14, that is 1 pi, whereas sine and cosine went over the span of 2 pi, right? Same thing goes right here. So this is half a pi, another half a pi. So this right here, this period is just 1 pi, 3.14. All right, so that is why we now change this formula up a little bit, and our period is equal to pi divided by b. Again, remember b is the coefficient in front of the x, right? So we're going to use that coefficient, we're going to plug it into the denominator, and that is how we're going to find the period for these transformed graphs. Okay. See, again, same thing, it's a phase shift, except now instead of us shifting the graph back and forth, it's actually going to shift our asymptotes, where our vertical asymptotes go. All right, so that now becomes a vertical asymptote shift horizontally. All right, and D, again, same thing, you're shifting the midline or you're shifting the central point vertically. So same thing here, D is going to make this central point go up or down. And here, let me show you in tangent. D, right, plus D at the end of the formula is going to make this central point go up and down, right? Just like it did before. Okay, so let's keep going, right? Notice, again, tangent is an increasing function. Negative cotangent is a decreasing function. Notice again, the central point is right at the origin, okay? Now take a look at cotangent. Cotangent is a decreasing function, right? And again, we have the vertical asymptotes wherever tangent is 0, all right? Cotangent itself is a decreasing function because wherever tangent increases, cotangent decreases. However, if negative tangent decreases, negative cotangent increases. These all look like the same graph, and I know. And that's what kind of makes it tricky, but that's also what's kind of helpful because you don't have to memorize all of these different shapes. You memorize this one snaky shape and just remind yourself what the positioning of this graph is supposed to look like, all right? Tangent is increasing, negative tangent decreases. All right, cotangent is decreasing, negative cotangent increases. They are inverse. They do the opposite of each other, yeah? All right, notice that negative tangent looks a lot like positive, or negative cotangent, sorry. Notice that negative cotangent looks a lot like positive tangent. These look very similar, yeah, as well as these, right? Negative tangent looks a lot like cotangent. They are very, very similar. Just notice that they are shifted because the vertical asymptotes have moved, right? So here before on tangent, where we go through the origin, here in cotangent, we avoid the origin, all right? And the reason that these graphs all look the same is because we're studying the same thing. We're still looking at a circle and we're just studying the different ratios of a circle. And it's like, well, how many different ways could you describe the different ratios in a circle? Not that many different ways, right? So that's why these graphs all look pretty similar because it's like, well, you can only do so much, right? Okay. So here's the suggested order that I think that you should do when you're given a general form and you're trying to do a transformation for a tangent graph. Do CBDA, all right? Start with C, all right? Find the horizontal shift. This is the opposite of what I would tell you when it comes to sine, cosine, cosecant, and secant, right? Sine, cosine, secant, cosecant. I would say do not start in this order, and I've created a flowchart for you all so that it should be hopefully a little bit more helpful. But when you're doing tangent, cotangent, this is probably the order you're going to want to do because I think it'll help you actually make your graph in a way that isn't too complicated. All right. Like I think that going C, B, D, A helps you take it one step at a time so that you feel like you're actually getting somewhere and making an actual graph. Okay. So starting with C, you're going to find the horizontal phase shift. All right, this is going to be where the vertical central line is. All right, so if we're looking right here, we're going to start with C and we're going to tell ourselves, where is this line right here on the graph? All right, normally for tangent, right, it would be x equals 0, right? Now, if we're looking at C, that's going to change things, right? That's going to move us horizontally, right or left, in the positive and negative directions, right? So we're going to figure out whether this line should be moved a little this way or whether this line should be moved a little that way, okay? So that's the first thing you want to do. All right, what you're going to do is you're going to set what's inside of the parentheses equal to 0, just like we did before. And then you're going to find out how much your graph has shifted horizontally, positive or negative, okay? After that, you're going to find the length of the period. Again, remember that our period formula has changed. So now it's P equals pi over B. Plug in B, solve for P. All right? When you find out your period, okay, when you find out your period, remember that the central line, right, is in the middle of that period. See, just like here, the central line is in the middle of the period. So when you find the period, you're going to take half of the period and add it. You're going to take half of the period and subtract it, and then you will find the period for tangent, okay? The central line is in the middle of your period when you're looking at tangent graphs, okay? And we'll do an example of this so you'll see what I'm talking about. After that, then you're gonna use D. You're gonna find the vertical location of your central point, right? So if here's your central point, you're gonna do D. You're gonna add, right? Usually it's like tangent of X plus 1, right? So that plus 1 on the outside at the very end, that plus 1 is going to indicate that this point right here is going to go up 1 unit, okay? Or if it's minus 1, this point in the middle is going to go down 1 unit, right? So you're gonna do that. And then you're gonna do A. That is your amplitude, right? That is when you're gonna add the other two invariant points, right? So if it's like 2 tangent of X, right? That means that your other invariant points, because there's 3 invariant points, your other 2 invariant points are gonna be 2 units above the central point and 2 units below the central point. And they're also going to be halfway between the central line and the asymptote, the vertical asymptote. So here, right? This is the amplitude. This has an amplitude of 1. So notice that this invariant point right here went up 1. And because the amplitude is an implied 1, this asymptote on the bottom over here went down 1 unit. And also notice that this asymptote on the x-axis is halfway between the central line and the vertical asymptote. Same thing goes here, right? Okay, so we've kind of broken this graph up into fourths, right? Here's 1/4, 2/4, 3/4, 4/4. Okay, same thing goes here. And then we just have to remind ourselves if we're looking at tangent or cotangent, whether or not it's an increasing or decreasing function. All right, so if it's a tangent, then you know that the invariant point to the right of the central point is going to be positive, and to the left is going to be negative because you need this graph to be increasing. For cotangent, right, you need your invariant point to the left to be positive in the y direction, and you need your invariant point to the right to be negative because we need this to be decreasing, okay? So here's an example, all right? Let's take a look at y equals the 2 times the tangent of pi over 2x plus 2 on the outside. All right, again, keep in mind, right, we're looking at C to B to D to A. So that's what we're gonna do. Right here, I'm just telling you real quick, we're gonna tell ourselves first, what is A, B, C, and D? So we plug those in. A is 2, B is pi over 2. C, we don't have, awesome, great. D is a positive 2, cool. Now, let's start off with C. C is 0, we don't have to worry about it. This graph is not shifting, okay? Left or right. So this central line right here, right where this point is not moving anywhere. X is 0. X is equal to 0. X is not shifting left or right for this central point right here. Okay, cool. So then we can move on to B. Well, B, we know, helps us find the period. So B equals pi over 2. So P equals pi over B. So we plug B in, pi over 2 just equals 2. The pi's cancel out. Fantastic, great, cool. So that means that our period is 2 units long. So you can see right here, right? Here's our central line, right? Again, for tangent, the central line is in the middle of the period. Central line is in the middle of the period. So we're going to add 2 and we're going to subtract 2 to find our vertical asymptotes. And that's exactly what we do here. So you can see right here between these 2 points, or between these 2 lines, this has a period of 2. The one vertical asymptote being at x equals 1, and the other vertical asymptote being at x equals -1. Okay, great. Then we solve for D, right? C, B, D, A. So then we do D, right? D is positive 2. So that means that this line that would normally be at the origin is now coming, or this not line. This point that would normally be at the origin is now going up positive 2. Okay? And then we do A, our amplitude, so we find our other invariant points. Okay? So that means that from this central point right here that we've established, right, our other invariant point is going to be a positive 2 up this way, right, in the vertical direction. And our other last invariant point is going to be -2 over here, okay? So for cotangent, it's just going to be a little bit different, right? When we're still going to do CBDA, except our vertical asymptote is no longer going to be our C, sorry. Our C is no longer going to help us find the central line. It's going to find the first vertical asymptote. Then we're going to solve for B, find the period, find the other asymptote, right? And then we're going to, again, just using the period, find the central point, use D to change the central point's vertical location, and then A to find the other invariant points. So here, if we're looking at y equals cotangent of 1/2 x minus pi minus 1, okay, the first thing we're going to do, right, CBDA, C, we're going to find out what our horizontal shift is. We have a horizontal shift here. Cool. So pi is -1. Well, what do we do with the horizontal shift? We take what's inside the parentheses, we set it equal to 0. Right? So we've got 1/2 x minus pi, that's equal to 0. If you do the algebra, subtract x, multiply by 2. Yeah? Or not subtract x. Subtract pi, multiply both sides by 2, you get x equals 2 pi. Great. So that is our first vertical asymptote. Right here at 2 pi, right, this arrow is 2 pi 6.28, right, approximately on the graph. This is our first vertical asymptote. Then we do B. We find that period. B equals 1/2. So P equals pi divided by 1/2, which is 2 pi. Awesome. So we know that this period right here is 2 pi. Great. So that means from here, right, going leftwards and going right, both in the horizontal direction, every period is going to repeat itself for 2 pi. Awesome. Great. We've drawn that in. Those are all of our vertical asymptotes now. Cool. We got the asymptotes out of the way. Let's keep going, right? So then we do our D, which is -1. Notice, normally, right, our central point would be on this x-axis. But now, since D is -1, we are going down 1 unit. And this is now our central point. Awesome. And last but not least, A. All right, our amplitude is 1, so that means from this central point, our two invariant points are going to be +1 and -1, right? And we know that these central points have to be halfway between the central line and the, what's it called? Vertical asymptote, right? And we know that this, because we're looking at cotangent, is a decreasing function. And so that's how you would do that. I know that that's a lot. I know that I went quickly, but I am making a flow chart to help all of you, and I need to join my meetings for the rest of the day, so I gotta head out. But if you all have any questions, please let me know. I'm going to try my best to like post more videos and stuff because I know that this is a lot of information. All right. Have a good day.